All right, in this lesson, we are going to learn about how to find the surface area of what we call composite figures. So composite figures are solids that are composed of two or more other solids. So you could have like a cylinder and a cone. You could have a pyramid and a rectangular prism, so on and so forth. Because in composite solids, all of the surfaces are not on the outside, and we want to find surfaces that are only on the area of the surfaces that are only on the outside of the figure, we often look at drawing a net or just breaking it down into the basic shapes of the outside surfaces. So the triangles, the circles, the rectangles that are on the outside surfaces, and find the areas of each of those and then add the areas together at the end. So let's take a look at this problem. So we want to find the surface area of the composite figure. So what we have is a rectangular prism and a triangular prism. And what we have to understand is that this piece right here is not an outside surface, so we don't want to include the area of that. So that's why our formulas either have to be modified or they just don't work. And so here I'm going to just demonstrate how we can use a net idea, breaking it down into just the individual shapes for the outside surfaces and then adding the areas together. So what I have here are, let's start with our triangles. So we have to understand we have two right triangles in this. This one in the front and its companion, which would have the same area in the back. So let's do that first. So we have our two triangles. And I'm just going to draw the triangle out here. So what I know is that this edge measurement is 3 centimeters. And I know that this edge measurement, which is parallel to this, is 4 centimeters. And so area of triangle, remember, is 1/2 times the base times the height. Or we can look at that as base times height divided by 2. And the base and the height in a triangle always form a right angle. So that means that our 3 centimeters is our height. And our 4 centimeters is our base. And so this will give us our 3 centimeters times our 4 centimeters divided by 2, or times 1/2. So that's 12 divided by 2, which is 6. So that's 6 centimeters squared. But I have to remember, I have 2 of these triangles. So I'm going to want 2 of those when I'm towards the end, and I'm going to add everything together. All right. Next, let's take a look at this right here. So this is a rectangle. What we notice about this is that this edge of it, the rectangle, is also the hypotenuse of this right triangle, which we don't know that measurement. So we're actually going to have to figure out what C is here to help us with the area of that rectangle. So I have a squared plus b squared equals c squared, my a and my b being the 3 and the 4. So 3 squared plus 4 squared equals c squared. And that's 25. And so C would be 5 centimeters. So that's this side. And it's also, we have this red rectangle here. The measurement of this edge right here. That's 5 centimeters. So that would be this. And then this other edge would be 2 centimeters because it's parallel to this edge down here. So that would be 2 centimeters. And area of a rectangle, remember, is length times width. So that gives us 5 centimeters times 2 centimeters, which is 10 centimeters squared. We only have one of these rectangles. So we have that as part of our total area. All right, so next we have this rectangle in the back. And so this edge again is 3 centimeters. This edge up here is parallel to this edge, which is parallel to that edge. So that's another 2 centimeter measurement. So we'll go with this, and we only have one of those rectangles. And so we have this 2 centimeters and this 3 centimeters. So that area is going to be 6 centimeters squared. Length times width again. And then, so that's all the outside surfaces of the triangular pyramid. The two triangles, or the triangular prism rather. The two triangles and the outside rectangles, this one and this one. So now we're dealing with the outside surface of the rectangular prism. And it doesn't really matter what we start with. I'm going to start with the front rectangle here. And I have to realize that this would also be the same area as the rectangle in the back. So I actually have two of those rectangles. And their dimensions, so this is 3 centimeters, so this is 3 centimeters, and this is 4. So they are 3 centimeters by 4 centimeters each. So their area would be the 3 times 4, which gives us 12 centimeters squared. And we have 2 of those. So we'll actually have a total of 24 when we're getting to the end. And then I have this rectangle here on the right. It's on the outside. And the one on the left that would have the same area. So I have 2 of those. And so those rectangles, so we have 2 of those. So they had dimensions of 2 centimeters and 3 centimeters. So each of them has an area of 6 square centimeters. We have 2 of those. So you can see keeping your work organized is helpful here. The one thing we now still have to do is the bottom. The bottom is considered an outside surface. So we find the area of the bottom rectangle. And its dimensions, as we can see, are 2 centimeters and 4 centimeters. So its area is 8 centimeters squared. All right, so now what we're going to do is make sure we're very careful about finding the total surface area. So going back and finding everything and adding them all together. So up here are 2 triangles. We're 6 centimeters squared each. So 2 times 6 would give me 12 for my triangles. So I have 12 centimeters squared. And then here I have one of these rectangles. So plus 10 centimeters squared. Here I have one of these rectangles, so plus 6 centimeters squared. Here I have 2 of these rectangles. 2 times 12 would give me 24 centimeters squared. Here I have just one, whoops, I lost my 2 here, I think. Did we do that? Yeah, because that's my triangle, so this one. So 2 of these rectangles, 2 times 6 gives me another plus 12 centimeters squared. And then I have this one rectangle that is 8 centimeters squared in area. So adding all of these together, we have 12 plus 10, which would be 22. 22 plus 8 would give us 28. 28 and this 12 would give us 40. 40 plus the 24 is giving us 64. 64 plus the 8 gives us a total of 72 square centimeters. And then we can write our conclusion, which is just that we're looking at the surface area of the composite figure. So the surface area of the composite figure is 72 square centimeters. All right, let's take a look at the next one. Okay, so for this one, it says this, we want to find the surface area of the composite figure in terms of pi. That's our pi. And to the nearest tenth. All right, so for this one, we're actually going to have 2 forms of our answer in terms of pi, which actually will be considered an exact answer, and then our nearest tenth, which will be our approximate answer. All right, so we have to recognize again what kind of figures we have here, what outside surfaces. So here, what we have to realize is we have a hemisphere, but it's a hemisphere without the base, because the base portion here is on the inside of this solid. So we're looking at finding the surface area of a hemisphere with no base. So we've learned that the surface area of that would be 2 pi r squared. And over here, we can see that the radius of this circle would be the same as the radius of the hemisphere. So that's our radius value, 5 centimeters. So that is going to give us a surface area of 2 times pi times 5 centimeters quantity squared. Now to do this in terms of pi, which is what we're going to do first, we just multiply the numbers together, not the pi. So we have 5 squared, which is 25. 25 times 2 is 50. So this part is 50 pi centimeters squared. All right, the rest of it, we have this circle, which is the bottom of the cylinder, and the side of the cylinder. Those are both outside surfaces. So we have the side of the cylinder, and one base, one circular base. So we have learned that when we flatten out the side of a cylinder, we get a rectangle, but that one of its edge, its length, is the circumference of the circle, which we calculate as 2 pi r, and the other edge is our height of our cylinder. And we've learned that the height of the cylinder is measured going from base to base, circle to circle. So that would be this measurement here of 14 centimeters. So this is our 14 centimeters, and our radius is again 5. So then our area of the rectangle, the side of it, would be our 2 pi r h, plus the area of one of our circles, which is our pi r squared. So this area is going to be 2 times pi times the radius of 5 centimeters times the height of the cylinder, which is 14 centimeters, plus pi times the radius of 5 centimeters squared. So again, we want to do this in terms of pi first. So we're going to just multiply the numbers. We have 2 times 5 is 10. 10 times 14 is 140. So that would be 140 pi centimeters squared. Plus, this would be 5 squared, which is 25 times pi, so plus 25 centimeters squared. And adding those two together, we get 165 centimeters squared. So now what we're going to do is find the total of all those outside surface areas. So we have our 50 pi and our 165, oops, didn't get my pi in there. Let's get the pi in there. 165 pi centimeters squared. Pi on that 25. So we have the 50 pi centimeters squared plus the 165 pi centimeters squared. So that gives us 215 pi centimeters squared. Now we're going to use our calculator to do a decimal approximation of that. And so we should get on our calculators that to the nearest tenth, which is what we're doing the approximate to, it's 675.4 centimeters squared. And then we can write our conclusion. So the surface area of the composite figure is 215 pi centimeters squared and about, or maybe we could say or about, 675.4 centimeters squared. All right, this is going to be just the end of part 1. You're going to want to watch part 2 to finish up all of your notes.